Hello friends, so in today's question, given the setup shown in the figure, blocks A, B, C have the mass, that mass of A block is capital M and mass of B as well as C is same. The string is assumed and unstretchable, the pulleys are frictionless. There is no friction between blocks B and the support table, but there is a friction between blocks B and C denoted by the coefficient mu. So we are going to find out three things. In terms of the given, find the acceleration of block A and the tension in the string connecting A and B. Second is, suppose the system is released from rest with block C near the right end of the block as in the figure. If the length L of the block B is given, what is the speed of block C as it reaches the left end of the block B? Treat size of C as small. In the last part, if the mass of the block A is less than some critical value, the blocks will not accelerate when released from rest. Write down the expression for that critical mass. So these are the three blocks. This should be B. A, B and C. A is having a mass of capital M, mass of B and C are small, and the length of the B block is also given as L. So in the A part, we are going to find out what will be the acceleration of A and the tension in the string which is connecting B and C. This is our first part. So before that, first of all, let's find out what will be the relationship between the constraint relationship between the acceleration of all the blocks. So we use constraint relationship between block A, B and C. So as B and C are connected with one single string, so let us say we have this block C and this is block B, and we assume that this A block moves in the downward direction, and similarly both the C moves towards left side and B moves toward the right side in this direction. We are going to find out, and let us say this is their acceleration A3 and this is having an acceleration of A1 and this is acceleration of A2. So we can say that C is moving with the acceleration of A1 and B is moving with the acceleration of A2, and they are connected with a string this way, and this string is fixed. So from the figure we can see that B is moving toward right, so let us call this as point 1, this is 2, 3 as well as 4. So length of the string between 3 and 4 is increasing, whereas the length of the string between 1 and 2 is decreasing, as C is moving towards left and B is moving towards right. Okay. From here we can say that the length of string between 1 and 2 is decreasing, therefore it will be minus of A1, and between 3 and 4 is increasing, this will be plus of A2. and we take their algebraic sum, because minus a1 plus a2 will be equal to 0. From here we can see that a1 is equal to a2. Okay, so acceleration of B and C will be same. Similarly, we can draw it for, or rather find the relationship between B and C and B and A. So we have our B, and it is connected with through a pulley like this, and we have this is our A. Okay, let us once again call this as 5, 6 and 7. So B is moving with the acceleration of a2 and A is moving with the acceleration of a3. From here we can say the length of string between 5 and 6 is decreasing by a2. So string length between 5, 6 is decreasing it will be minus of a2, and between 6 and 7 it is increasing. Between 6 and 7 is increasing, so we have plus of a3. So we can say that minus of a2 plus of a3 will be equal to 0. From here we can say that a2 is equal to a3. So let us call this as equation number 1, and this as equation number 2. So from equation 1 and 2, from equation 1 and 2, we get that a1 is equal to a2 is equal to a3, and let suppose it is equal to a. Okay, so it means acceleration of blocks C. Okay, so we can say acceleration of block C is A, block B is also A, and block A is also A. So block C will be towards left, block A will be towards right, and for block A it will be in downward direction. So these are our respective accelerations, and now we can draw the free body diagram for all the blocks. So let us draw first of all for B and C. So this is our block C, and this is our block B. So block B is connected, let us suppose the string is having a tension T, and block B is moving towards the right, so it will try to force block C towards the right, let us suppose with a friction Fr, and there will be equal and opposite Fr on B also, and there is a tension, let us suppose T1 here, and similarly it will also have T1. And acceleration of block C in this direction, and this will be acceleration of A. And for A block we have mg, and we are going to have a tension T, and it is moving in the downward direction with the acceleration of A, and there is a friction between B and C. Okay, so you can say this is going to have mg downward direction, and there was normal n whose value will equal to mg. So from here we can say our fr will be equal to mu n, which is equal to mu mg. Fr will be equal to mu mg. Now we write the respective equations for each individual block. You can say that for block A, we write the equation as mg minus t will be equal to ma. Okay, and from here we can find an equation for t. T will be equal to mg minus ma, and let us call this equation number 3. Next is for block B. Okay, so we can write for block B we have T minus T1 minus FR is equal to MA, and this is our equation number 4. And we have for block C we have T1 minus FR will be equal to MA. From here we can find our T1. So we can say T1 is equal to MA, FR is mu mg, so we put value of mu mg. This is equation number 5. Now we take the value of T, T1 and FR and substitute it in equation number 4. So write from equation using equation 3 and 5 in equation 4. So value of T was equal to mg minus ma, so we write mg minus ma, and we have minus of T1. T1 is our ma minus mu mg, and we have FR minus mu mg will be equal to ma. Okay. One second. I think it will plus, my mistake. Yeah, that's correct. So we just open the bracket. Okay. We get mg minus ma minus mu mg. We have minus mu mg and is equal to ma, so small ma. Now we combine the similar terms. Okay. So we get this as mg minus 2 mu mg rather. This will be equal to ma, and ma will be 2ma, and we take a as common, so we have 2m plus capital M, and from here we can find out the acceleration over a will be equal to, we take g as common, so we write m minus 2 mu m divided by 2m plus capital M g. G. So this is our acceleration of block A. Acceleration of block A. Next, we are going to find out the tension T, and we already know the equation. Okay, the equation is T is equal to mg minus ma. In this equation, we substitute value of A, we get mg minus m, and A is our m minus 2 mu m divided by 2m and into G. We can take G common from the entire part. We get G, taking LCM also. So we have 2m multiplied by m, and this will be plus m square, and we have minus m square, and this will be minus and plus 2 mu m into capital M divided by 2m plus m. This m square cancel out with m square. From here we can take 2mm common. So we get this as tension is equal to, denominator is 2m plus capital M, and numerator we get 2m mg, and we get this is 1 and mu. So this is the tension of the string between A and B. This. Now in the B part, we have to find out that it is given that this is blocks B, which is having a length L, and block C starts from this extreme, and we are going to find out what will be its velocity with which it reaches by traveling the distance L. Okay. And we already know that B is moving towards the right and C is moving towards left with the acceleration A. So there is a relative acceleration between both the blocks. Okay. So we can use the formula which states that v square is equal to u square plus 2a s as the relative motion between the blocks. So we can simply use the term relative. Okay. And the s relative is given as L, and a relative, they are in opposite direction, so we have a relative coming as 2a, and block C starts from rest, so it means u relative will be equal to 0. So we put all these values in this equation, we get this as v square relative is equal to 2 is 2a into L. So we can write this as 4AL. Okay, and we substitute value of acceleration A. Okay, so we can write this as v square relative is 4 multiplied by A, and our acceleration was equal to m minus 2 mu m divided by 2m plus capital M multiplied by g. So taking the square root, so we get v is equal to square root of 4lg multiplied by m minus 2 mu m divided by 2m plus capital M. So this will be the acceleration of block C, acceleration of block C when it reaches to the left of block B, left end, or rather let me put over end, left end. Okay, and in the last part we are going to find a critical value of mass of block A such that acceleration is 0. So in this case we already know the formula for acceleration. The formula for acceleration is given as m minus 2 mu m divided by 2m plus capital M g. So we put A is equal to 0 in this equation because acceleration is said to be 0. Putting A is equal to 0, we get m minus 2 mu m will be equal to 0. From here we can find out that capital M, or rather mass of A, will be equal to, should be equal to rather, twice mu m. So if this condition exists, then we can clearly say rather that there will be no acceleration. So this is the critical value of block A. For which there will be no acceleration, for which there will be no acceleration. So this completes all the three parts. Thank you.